So question 5 says the lifetime L hours of a battery has a normal distribution with mean 18 hours and standard deviation 4 hours. So writing that in maths, L has a normal distribution, mean 18 and standard deviation 4. So 4 squared is the variance. Alice's calculator requires 4 batteries and will stop working when any one of the batteries reaches the end of its lifetime. Find the probability that a randomly selected battery will last for longer than 16 hours. So it's the probability that L will last longer than 16. And there's only one mark, so it should be relatively trivial. So putting that in the calculator, we're going to normal distribution mode. And it's the normal cumulative distribution. So the lower bound here is 16. So I'm sure your teacher told you to always do a sketch. So the mean is in the middle, 18, and 16 is there. So 16 is the lower bound, and the upper bound is infinity, which we can just put a very large number on. So let's just say 99999. So the standard deviation is 4, and the mean we said was 18. Therefore, it's 0.6914 is the answer, 0.6914. So the next part, at the start of her exams, Alice puts 4 new batteries in her calculator. She has used her calculator for 16 hours, but has another 4 hours of exams to sit. Find the probability that her calculator will not stop working for Alice's remaining exams. So we're given that this situation here has occurred. So we want to calculate the probability of something, given that it's lasted longer than 16 hours. So the probability that we have to calculate is the probability in total that we get more than 20 hours of battery life, because it's already worked for 16 hours and we want another 4 hours. So in total, that's the probability that X is greater than 20. So the denominator is going to be the probability X is greater than 16. And we're calculating the probability that X is greater than 20 overall. So if you want to have a look at my conditional probability video to see how these given that probabilities work, you should maybe have a look at that. So have a look on the YouTube channel, search for conditional probability, and that'll explain in more depth. So the probability that X is greater than 20 equals, let's put it in here, so lower bound 20, upper bound 9999, so 0.3085. 0.3085. So then, doing the probability up here, calculating that, we've got P equals 0.3085 over 0.6914. 0.3085 over 0.6914 equals 0.4462. However, that's only the probability that one battery will last that long. This needs to happen for all 4 batteries, because we'll read here, right at the beginning, that the calculator will stop working when any one battery reaches the end of its lifetime. So we need all 4 batteries to follow this probability here. Therefore, P to the power of 4 is our answer, which is 0.4462 to the power of 4. The power of 4 equals 0.0396. So the next part says Alice only has 2 new batteries, so after the first 16 hours of her exams, although her calculator is still working, she randomly selects 2 of the batteries from her calculator and replaces these with 2 new batteries. Show that the probability that her calculator will not stop working for the remainder of her exams is 0.199 to 3 significant figures. Right, so there's a couple of things that will need to happen here. So we're using 2 of the old batteries all the way through. So we need this to happen not 4 times, but twice. So we want that to happen. So P equals 0.4462 squared. So as I said, 2 of the original batteries have to last all the way through. So that's the initial probability twice rather than 4 times. However, we want the 2 new batteries each to last more than 4 hours. So let's calculate the probability of a battery lasting more than 4 hours. So normal cumulative. So the lower bound this time is 4 hours, upper bound 9999, standard deviation 4, the mean was 18, and that's 0.999767. So equals 0.4462 squared times, and that'll be stored in the answer button. So 0.999767 squared equals, so let's go 0.4462 squared times our answer squared equals 0.199. So we've shown it. So next question. After her exams, Alice believed that the lifetime of the batteries was more than 18 hours. She took a random sample of 20 of these batteries and found that their mean lifetime was 19.2 hours. Stating your hypotheses clearly and using a 5% level of significance, test Alice's belief. Okay, so first of all, let's define what we're testing. So we're testing mu, which is the mean lifetime of a battery. Our null hypothesis was that all was well and our assumption of 18 hours was correct. Our alternate hypothesis was she suspects that they last more than 18 hours. And we're not testing L anymore, we're testing L bar, which now has the distribution 18, but the variance has changed. The variance is no longer 4 squared, the variance is 4 squared divided by the sample size when we're testing for the mean. If you want to know why that is, go and have a look at my video on testing for the mean of a normal distribution, but we're going to assume that you know how to do that and just want a bit of guidance here, so we'll carry on. So now we want to find the probability that L bar is greater than our our observed number. The reason is we know that it's a greater than test here. So equals, let's put it straight in the calculator. So it's a normal cumulative distribution. The lower bound 19.2, the upper bound infinity. The standard deviation is now the square root of the variance, which is 4 squared divided by 20, all square rooted. And the mean is still 18. So the answer is 0.08986. 0.8986. And that is greater than our significance level. Therefore, do not reject H0 and then a conclusion in context, insufficient evidence. To suggest that the mean lifetime of a battery is more than 18 hours. Has to be in context. So that's the end of the stats section of the paper. So the next video will be on mechanics. For more videos like this, subscribe to our YouTube channel, and to find out more about our Skype tuition and revision courses, go to alevelmathsrevision.com.